Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of rate of change. This is standard A.3B in the great state of Texas, and we are using item number 34 off the 2022 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a table here showing a linear relationship between the distance in feet below sea level and the time. Okay, so we're looking for the rate of change of the distance of feet below sea level with respect to. So let me just kind of box that right there, because that plus this rate is going to give us a clue as to what we're looking for. So with respect to can be rewritten as per. So what we're looking for is the distance in feet below sea level per time that the submarine traveled. When we put that with rate, which also can be written as ratio, that's going to give us our clue that, all right, we're looking for a ratio or a fraction here. And what we're looking for is distance in feet below sea level. So I'll just write distance per, or distance with respect to time. So distance over time, or distance per time, that's the ratio we're looking at. But we're looking at the rate of change. So I'm going to include this triangle. It's actually the Greek letter delta. We use it in math and science to signify change. So the change in distance over the change in time. That's what we're looking for. Now, it's the time that is going to be our independent variable, because that's what drives the distance. The longer that we are going through this dive, I guess, the longer or the deeper we're going to get to the distance below sea level. So that's our independent variable, which means our distance is our dependent variable. And typically we will call our independent variable our x, because that's our domain. Our dependent variable is typically called y, that is our range. So really what I'm looking for is the change in my distance is my y, over my change in x, because my time is my x. Hopefully you're thinking change in y over change in x, that sounds an awful lot like slope. And if you're thinking that, you are correct. All of this rate of change is really just looking for the slope. So how do we do that? Well, that's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's just pick any pair that we want to. And let's go with this and this. We can pick any pair we want to. Let's make this, I want to make that x2, x1, as long as the other pair is paired up exactly. So x2 is across from y2, x1 is across from y1. Okay. So that means I'm going to have 604 minus, that's my y2, 876. My y1, and then I've got my 18 minus my 52. So if I were to have flipped those and made this 18 my x1 and my 52 my x2 would give me the exact same numbers, it would just reverse the sign. Rather than being negative, they'd both be positive. And since both of these are negative, it's going to end up as a positive anyways. So let's get our calculators out and let's say, what is 604 minus 876, that's minus or negative 272, and then 18 minus 52, negative 34. So like I said, they're both negative, so they're going to end up as a positive. So what is 272 divided by 34? Gives us a nice round number of 8. So for every second that goes by, this submarine drops 8 feet. 8 feet per second is what we're looking for. Now, this is a free response, so this is what you would see right here. You would see 7 boxes. You'd see your positive and negative over here. You don't need to bubble in the positive. It's automatically assumed to be positive, and you can just put the 8 anywhere. So go ahead and put it there, and just make sure you bubble that in. And that's your answer, 8.